let's continue with trig number 3. I think we're on page 159 in your workbooks. So let's take a look at class example number 3. And I think this one is similar to some of the other ones. One little missing piece, but I think it's pretty straightforward for you guys to figure out. So again, please hit pause, try the question, and you'll come back and hit play again, and I'll have an explanation for you. So in class example number 3, then, we know that it tells, we already know that we're talking about the third quadrant. Sine of A is equal to negative 4 over 5. And so since the sine ratio is y over r, then we know that y must be negative 4, which is why they've indicated that right here, that y is negative 4. The negative in front either means that the numerator or the denominator is negative, but since our r value, our radius, is always a positive, that's why the y is negative 4. So that's where we've drawn that in. And so then we can calculate what our x value is using x squared plus y squared equals r squared, or manipulating that around, r squared minus y squared equals x squared. So x squared is equal to 9, which means that x is going to equal plus or minus 3. But since we're talking about quadrant 3, we know that in quadrant 3 all of our x values are negative. Therefore x is equal to negative 3. Once we have our x, y, and r values, we can simply substitute them into our ratios. So that cosine of A is negative 3 over 5, tangent of A is positive 4 over 3. And again, it makes sense looking at the cast rule that in quadrant 3, the only ratio that is positive is our tangent ratio. So let's take a look at class example number 4. It tells us that tangent of theta is equal to negative 2 over 3, and cosine of theta is positive. So if tangent of theta is negative and cosine is positive, then we have to be looking at quadrant 4, because that's the only place where we have a positive cosine but a negative tangent ratio. So you can see that I've sketched in a terminal arm, because tangent of theta is equal to opposite, or y, over adjacent to x, then we know that we're dealing with a negative y value in quadrant 4, and so that tells us that we're looking at negative 2 for the y value, and x is then 3. So we can write that in, that x is equal to 3, y is equal to negative 2. I can even label that point on here as 3, negative 2. Let's then solve for r, because sine of theta is equal to opposite y over the radius, so we need our r values. So again, we're looking at r squared is equal to x squared plus y squared, or 3 squared plus negative 2 squared, or 9 plus 4 is 13, so r squared is 13. R then is equal to the square root of 13. So then our sine of theta is going to equal y over r, or negative 2 over root 13, rationalizing the denominator by multiplying top and bottom by root 3. 13, sorry, we have negative 2 root 13 over 13 as our exact value of sine theta. Good. Let's pause that there. So on page 160, what we're going to be looking at in examples 5 and 6 is how to solve for an angle when you're given the ratio. So let's take a look in class example number 5. It says to solve sine of theta is equal to 0.5, and we're looking at the fact that theta is going to be anything in between 0 degrees and 360 degrees, so it could be in quadrants 1, 2, 3, 4, or 4. But the key thing is recognizing here that since sine of theta is something that is positive, then if we look at the cast rule, then that tells us if sine of theta is equal to positive 0.5, then we're looking at positive in either quadrants 1 or 2. So just write a short form, Q1 or Q2. So we can now use our calculators and ask our calculators to do the inverse sine. So if sine of theta is equal to 0.5, then using your calculators, making sure, of course, that you're in the degree mode, then the inverse sine of 0.5 will give you theta, and it tells you that theta is 30 degrees. But if we take a look, 30 degrees is of course just in quadrant 1. So what it's actually telling you is that it's telling you that the reference angle is 30 degrees. So if we take a look then in, let's draw another axis here. So if I have 30 degrees, here's my reference angle, or in quadrant 2, 30 degrees, here's my reference angle. So then what is the actual rotation angle is going to be 180 minus 30 degrees, and therefore theta is either equal to 30 degrees or 150 degrees. So the same thing goes then for class example number 6. So taking a look, if sine of x is a negative value, then we're talking about either quadrants 3 or quadrant 4. Let's just work our way across. If cosine of x is again a negative, we know then that in quadrant 4 is when cosine is positive, as well as in quadrant 1. So then this must be either quadrant 2 or quadrant 3. When tangent is negative, then we're looking at either quadrant 2 or quadrant 4. And so with that, that tells you where you will draw your reference angles as to when is it relevant. So again, let's take a look in your calculators. You can put in the inverse sine of 0.8090, and that gives you x, and x being your reference angles. So do that for those 3, and then draw out the pictures, and then come back to the video. So pause it for now. So if we take a look and enter into our calculators the inverse sine or the inverse cosine, inverse tangent of the ratios, if you notice I actually left out the negatives in front because I already know I've accounted for them by knowing my cast rule and knowing which quadrants they're going to end up in. So with quadrant 3 or quadrant 4, with that being 54 degrees as my reference angle. If I'm talking about this particular rotation angle, it's going to be then x is equal to 180 degrees plus 54, or x is then equal to, if I look at my other reference angle this way around, then it's equal to 360 degrees minus 54 degrees. So that tells me that x is either 234 degrees or x is equal to 306 degrees. Let's switch colors just so we're not too confusing here. So in quadrant 2 or quadrant 3, if my reference angle is 36 degrees, then in this particular case, that rotation angle x is going to be 180 degrees minus 36 degrees, or x is going to equal then 180 degrees, plus 36 degrees. And so x then is either equal to 144 degrees or 216 degrees. And the last one, we are talking about quadrant 2 or quadrant 4, and our reference angle is 68 degrees, and so then x is either equal to 180 degrees minus 68 degrees, or x is equal to 360 degrees minus 68 degrees. X is either equal to 112 degrees or 192 degrees. Good. Let's take a look at the last two class examples, class examples 7 and 8 on page 161. So pretty similar as the other ones. Sine of theta is equal to 1. Since it's positive, then we know that we're talking about either quadrant 1 or quadrant 2. And so if we put into our calculators inverse sine of 1 to give us theta, what we find is that that reference angle is actually 90 degrees. And so that means that, say that, there it is right here. So what we can then think through is, well, if it's quadrant 1 or quadrant 2, then if theta is equal to either 90 degrees, or if we think about anything that ends up in quadrant 2, how are we figuring out what the rotation angle is? We're taking 180 degrees minus the reference angle, which happens to be 90 degrees, and guess what? Either way, we end up with the same thing. That theta is then 90 degrees. Same thing for cosine theta is equal to 0, because 0 is neither positive or negative, then we have to take a look at all quadrants. Then, and so if we take a look and do the inverse cosine of 0, what we end up with is our reference angle is, again, 90 degrees. So if it's quadrant 1, then we simply look at our reference angle is our rotation angle. So if it's quadrant 1, then we know that theta will equal 90 degrees. If it's quadrant 2, then we know that theta would equal 180 degrees minus our reference angle, which is 90 degrees. If it's quadrant 3, we're looking at theta being equal to 180 degrees plus our reference angle, which is 90 degrees. And if it's quadrant 4, theta is equal to 360 degrees minus the reference angle, which is 90 degrees. So if we figure these out, quadrant 2 is 90 degrees, quadrant 3 is 270 degrees, quadrant 4, 270 degrees. So you can see that there's a repeating happening, and so theta is either 90 degrees or 270 degrees. Satisfy that equation. So same thing goes for class example 8. The only thing that we want to pay attention here is that theta must be less than 180 degrees. So if we subtract 1 from each side, then we have 3. Tan of theta is equal to 3. Divide both sides by 3. Tan of theta is equal to nothing spectacular happening there, because it's positive. Where we're looking then is 1 only, and because if you think about it, well, why is it quadrant 1 only? Some people are probably thinking, well, wait a second, for our cast rule, quadrant 3 is also positive. The tangent of quadrant 3 is going to be greater than 180 degrees. So that's why we're only looking at quadrant 1. So if you look at the inverse tangent of 1, then theta is equal to 45 degrees, because that's the only one that's valid. Okay, great. So please have a look at Manage Back and complete the assigned questions.